Right, another mailbag segment already. I did one yesterday, time for another one. Let's had some more stuff turn up. We'll get to these shortly. I purchased these of eBay. For now, I need this and my knife, which I can't currently get to, so you have to use this one. Right. Got here. Oh yes, okay. I bought this from a company, a local company, New Zealand, PB Tech. 64GB USB 3 flash drive. Not bad little thing. It's fairly cheap considering the size. It's like $23 or something like that. It was. Yeah, that'd be quite good. I find a use for that. I wished I had one a little while ago. Oh yeah, just some 10k pots. They should be 10k anyway. There we go, 10k on the front. So yes, we'll wait for those to turn up. That's another, that's a AliExpress purchase. So that's one more of those things sorted out. Another AliExpress purchase, some transistors, 3904s, surface mount. Some 10k resistors. I think that's what they are. And some diodes, power diodes. It's like, can't remember the code on it. I think it's like 41004 or something like that. It was, or 4004s equivalent surface mount. What else we got here? Those are for my revised modification boards. Oh yes, okay. I bought a another USB 3 card. I should have actually done a video on the other one. I purchased a USB 3 card on eBay, and it arrived and it didn't work. So I got hold of the seller, and he was all really good about it. So let's just send it back, and I'll send you another one. I'll cover the cost of postage and stuff like that. So it's all good. But I never quite got around to it. It's a couple of weeks later now, and it's like, oh, okay, I'll have a look. And so what I ended up doing is having a really good close look at the card, and I found the crystal on the card wasn't soldered down, which is why it doesn't work. So I actually repaired the card, and I let the seller know. And again, the seller was really good about it, and said, he was quite pleased I was able to repair the card, because it ultimately saved him money for not having to send it back and send me a new one. And he actually gave me a partial refund, which is really good. But in the meantime, I actually purchased another card, and that's what this is, another USB 3 card. So look at this. Also not static safe, but I don't tend to wear nylon or anything, so it should be fine. Yeah. Innertech apparently. This uses the Fresco Logic FL1100 chip, which is compatible with my Mac Pro, native compatible. So it's all good. So I might actually swap the card out, which I've got in there now, with this one. This has actually got 5 ports and a couple of internal ones as well, but it's also got onboard power. So we should look at that. I might swap it out in the end anyway. This might be a slightly better card. But then I don't really have much in the way of USB 3 stuff anyway. So anyway, that's those mailbag bits done. Now this is where we get a bit more interesting, but let's get the rubbish out of the way. Boonton modulation meters. I purchased these on eBay, and I purchased them both as non-working for parts. They actually came together from the same seller, the same batch, so I bought them as a single item. Now, all I've done is take the packaging off, already opened them up because they're in a massive box. But this one, I'm pretty sure that they're not meant to rattle when you move them around. So yeah, I'm going to have to open that one up and have a look. I already opened the other one up a little bit just to have a little peek in there, so I've got an idea what it could be. So let's just have a look. Screws are loose already. One of them did say that it came with no cases on it, so I'm expecting there to be issues. I mean, my intention was to purchase them both as faulty units and try and use them each to fix the other one. So, what's rattling? Oh look, batteries. Here we go. Okay, that's what's rattling around inside it. A couple of batteries. Alkaline batteries. The other unit has batteries in it as well. I've already taken the cover off this one, which is why I had a clue what might be these ones here, but they're already all corroded. There's all corrosion down the ends of them, so that holder and everything's probably stuffed. So I just got these. I opened it up last night to have a look, so I'll get to that one shortly. So yes, that's what the inside of it looks like. Try and get a better view. I'll take it sideways. There you go. So lots of interesting logic in there. Battery pack thing is interesting. I'm hoping it doesn't require the batteries to be in there to retain its configuration memory or something. I've got no idea. I haven't read the manuals for these yet. I knew it was a modulation meter and that's what I wanted. So I've got this big Marconi sitting right here. I've also got a rag-hole Dana sitting on my shelf there too. But I tend to use the Marconi, really. It just works better. But I thought I'd give one of these a go and see what these are like. I mean, these are Boonton, so it's another good brand, and it looks, you know, it's much more compact. I can fit that on my shelf much more easily, and hopefully it'll do the same job as the Marconi, pretty much. I don't actually use the Fuchs account on Marconi. I use the my other ones. So I might sell that on if this works out okay. So visually, I'm not seeing any obvious faults. I've already switched the power switches on the back just to make sure I don't forget to do it when I plug it in. As far as whether these work or not, I don't know. We'll find out very soon. I'll grab a lead and plug it in. But now there's nothing rattling around or anything, so it was just those batteries. So, right, let's go and get a power lead and some new batteries. Probably those are probably flat anyway, and we'll see what happens. Okay, so I've plugged in the power, hooked up my test lead here, which I've got going to my signal generator, so I can generate a audio signal to voices into test. Let's power it up and see what happens. Well, at least it lights up. That's something. Okay. I think it's waiting for a signal, so let's chuck a signal in there. Carrier turned on. IF low. Modulation is on. Right. IF low. I wonder what that means. Buffer IF low. That's interesting. Now what? I really should read the manual. Looks like the input is just a bit too weak for it. I'm currently putting out 800 millivolts at 30% mod on AM. So what I might try doing is doing FM instead, because that puts out a slightly stronger voltage. Because then let's try and modulate it that the same way with a 2.5 kilohertz modulation. See if that helps it at all. No, nothing. Okay, so I'm going to have to read the manual on this and just figure out what's going on. So what I'll do is let's go off again, and we'll just try the other one. Plug the other one in, see what happens. If I get the B and C back off again, it'll be good. Hopefully the other one doesn't go bang. Mind you, actually, I'll stop the camera for this one because I've got to clean up the battery terminals first. That needs sorting out really before I can do anything else. So I'll do that first. Okay, so I've just pulled those other dirty batteries out. These are actually Energizer industrial batteries, so they should be decent quality, but they've leaked quite severely. You can see that actually, but yeah, I mean, I've see this cradle on my desk just here. That's what I've just scraped out of the connector. The connector doesn't look like it's corroded, so it's good. Oops. So I was getting a little bit of a spray of some IPA. I'm going to clean up some more, just try and give it a good flush out, try and get rid of anything which might still be there to affecting it, which might cause it to corrode. Then I'll put some new batteries in it. Then I'll power it up. Okay, I'll just put some new batteries in. Takes AAA's. Let's hook this thing up and see what happens when I power it. Just double check the power. Yep, set to 240 volt. So these are both purchased as faulty units, or not working, you know, which is usually a cop out, but I said it in case it doesn't work properly when someone gets it, because I don't really know what they're actually trying to sell. Because they can trust it because they're just buying and selling stuff, so they don't actually know whether it's okay or not. So sometimes you get perfectly good stuff. Other times, yes, it does actually have faults. So you never quite know. The other one's saying IF low. I don't know whether that's a fault or if it's just a thing on the manual. So, right. Let's power this thing up. Now the other one did actually say that the first time I powered it, after I first put the batteries in, I did power it up. I did say that cal thing first. Then the second time I powered it, it didn't do that again. So this is what you're seeing is for a fresh start. It's got new batteries put in. Just like it loads its calibration data somewhere, or does a self-calibration, and then stores it with the batteries as a backup. So it's like a shortcut for power up. That's the way it appears anyway. So question is it doing what it's meant to be doing? I've got 1 volt output from my signal generator, 2.5 kilohertz deviation, so it's not registering anything, but level showing nothing. The other one was showing a level. So as far as where these are sitting, I'm not sure. That button there is a bit dirty. So IF level is 0.14. The other one's saying 0.1, 1 point something. Was it 1.6? So let's just see if it's actually changing with levels at all. If I go 0.9 volt, it didn't change. 0.5 volt. Yeah, so it's not changing at all. So this one does have a fault. It would seem it's not actually detecting the signal. So let's going back off again. Let's go back to the other meter. So the idea was to make one good meter out of 2 bad ones. So I'm not surprised there's a fault which needs to be resolved. But I was kind of hoping that they both just work, because that's, you know, a bit of a gamble you take, isn't it? So let's try this one again. So I just want to see how the level looks. Saying 0.7, but the same input level as the other one, saying 0.14, wasn't it? So it's 0.64. If I go to 0.8 volts, that increased. Awesome. I wonder what that is. Actually measuring in. So it does seem to be responding to the actual changes in input voltage. So this one's actually seeing the signal, and it's responding to that. Whether it's the correct level, I don't know. It might just be that the signal level I'm using is too low, because I'm using an IF generator, not a transmitter. So it could just be this one does actually work. So I might just hook this up to a radio actually and just see what comes out of that. Yeah. Okay. Well, I really should read the manual. So what I'll do is I'll go away and I'll go and read the manual and come back and actually have an idea what the hell I'm doing there. Okay, so I just pulled the bottom covers off both of these units, having a little look around, and I just looked at the unit which I think this one was showing low AF, and what I've noticed is just here there's a burnt resistor. So okay, there's probably a shorted capacitor somewhere or something, and there's tantalum right there, or tantalum right there, and that resistor there looks interesting. I'm not sure why it's different types, because I come to this radio, or this unit, like that. That one looks okay. But at least that one's got the codes on it, so I can use the codes from this one to replace this one. Done. Of course, I can always look at the service manual and pull it up from that, because I do actually have the service manual. But obviously that resistor's burnt for a reason. Finding out why could be interesting, but I might just go around this board, pull this board out, and check all the capacitors on it and see if I can find any problems there. It's entirely possible that a tantalum capacitor's gone, but at least I've already found one fault. So it's just interesting that that resistor there is that colour. It's still got the markings on it. It's not actually burnt, so it's just a little bit odd. You know, I don't know me. Don't know why it's like that, but that one there's definitely gone. So at least that gives me something to go by. I'll have a look at the diagrams and trace that out and figure out where that goes. It's obviously got some kind of fault which has burnt that. It wouldn't have just gone by itself. I can't see any other burnt parts on here. I haven't tested the power supplies yet. So I haven't actually done that part yet. I'll sort of just do a little visual inspection and see what I can see first. Let's try the other unit. It's handy getting two, because then at least I can do comparisons, which is why I was quite keen to get the pair. You know, it's a bit of a gamble getting both, but yeah, that's right. So I'm just doing visual stuff first, then I'll worry about the more detailed. Interesting thing is, some of these parts, like on this one here, they're socketed. Some of these parts are socketed. That's on the socket, that's on the socket. So is that on there? It's actually 555 timer, which is interesting. And these aren't. So I'm not quite sure why I've done things differently. Maybe the units had some repairs done in the past, who knows. But that's where we're at right now. So far I found one fault. I'm going to maybe turn this order back over and look at the other side. Let's do that now. You can see it's actually got writing on it, so someone's actually worked on this in the past as well. Let's just have a good look on this side. I didn't actually notice any burnt parts, but maybe I'll just have a closer look now, in case there is something there. The jumpers are on the same positions in both, and the little limit switches and stuff, which are at the front, they're all in the same places. It's all tucked in under there, which is a bit tricky as well. Voltage regulator in the back there. There's nothing obvious that I can see from back there anyway, but yeah, it all looks okay in that one. The top of all these boards is actually quite simple, just all the logic, that's all, but yeah, this side looks okay. There's nothing I've seen anyway, not yet. So, and the power supply on this one you can actually get to. See, it hasn't got the cover on there. This has got the cover on it, so I might just take that cover off so I can access it and do some voltage checks. But it all seems to be pretty much okay. I can't see any signs of leaking caps. I mean, this one's looking, that's looking slightly bulgy. It is looking slightly bulgy, so I think that might need changing. It's got a very slight bulge in it. I'm actually wondering if this one's already been changed. Who knows? Anyway, I will carry on with my testing. Right, let's go do some power supply checks. I've got this one set up. I'll do one, then I'll do the other one. I'll just do comparison side by side. I know this one's got a burnt resistor, so we'll see how that goes. Hope you can see the meter there. So I need to find TP5 first, which is a positive 15 volt power supply. I just need to find it. There's TP6. TP5, there we go. So stick that on a negative there. TP5. Bang on 15 volts. Look at that. Perfect. That's good. Now I need to find TP2, which is negative 15 volts. TP2, where are you? Okay, figured this out. There's a little pin pad here, which is where the TP5 marking is. The other pins are also labelled 1 through to 5. However, they actually refer to test points. So that's pin 5 as TP5. Pin 4, which is TP4, which is 5.1 volts, and that is just within spec as at the top end. Pin 3 is minus 7.5 volts, which is correct. Pin 2, which is jumped to pin 1, is minus 15 volts exactly. So the voltages here look bang on. So far I've got to do one more yet, which is pin 24 of U11. Yeah, I've got to find out where U11 is first. I'll come back to that. Okay, I've managed to find the parts layout of the diagrams. So U11 is actually the EEPROM, which is just over here in this corner here. So let's just measure that. Pin 24, which would be that pin there. 5 volts. Yep, that's fine. So the voltages there, check out. I just need to check ripple to ensure the power supplies are okay, but that capacitor's bulging. I don't like that. This probably is an issue there. Okay, so I've just taken the capacitor out, which I'm suspecting is dodgy because it's very slightly bulged. Although I tested okay, I'm going to replace it anyway. And I noticed when I desoldered it, the tinning on the track, just down there, see that? It's got corrosion underneath the tinning. So the tinning's come off and the copper's actually corroded underneath. I actually found it on the bottom of the board as well. There's a little trace which I noticed didn't have any tinning on it, and it's all corroded. So that's an interesting thing to watch out for on these. For the copper corrosion underneath the tinning. You know, see, this all looks absolutely fine, but actually it looks like that really. So that's an interesting little thing to watch out for. Okay, so I just pulled this board out that was in here, which has got the burnt resistor on it, which is there. Let's pull this out to try and see what that goes to, and it actually goes back down to this. Let's put the board down on. So this actually feeds down to this plug here, to that central pin there. Probably, I don't know, it would be pin 1 of it. I don't know. Which then goes to this plug, which disappears in the back of the front panel. So I'm not quite sure what that does yet. The other side of that resistor goes through, trace there to a diode. Which then goes to the IC, and also bridges off to the other diode. And that resistor there. So I'm just trying to trace through this right now. I'll have a look at the circuit diagram. It goes back to that same IC, which is a what's that? LF356N. So it's a bit concerning. There's a burnt resistor there. Does that mean that chip's gone? I wonder. You know, it's concerning. Very concerning. So I'm going to replace that resistor anyway. And whilst the board's out, I'm going to test every capacitor on the board and just make sure they all look, you know, kind of okay. And then I'll go from there. Okay, the only 600 ohm resistor I had is massive, so anyway, that's there. So I've replaced that now. So it's a 600 ohm resistor. That's marked as R76 on the diagrams, and it's the AF output from this IC here. So I'm hoping that this IC is actually okay still. With that being burnt out, who knows. That runs off the plus minus 15 volts supply to give the AF output on the front panel just there. So I'm guessing someone at some point has plugged something into the front which they shouldn't have done and has blown it. So it's unlikely to be related to the fault I'm experiencing, unfortunately. So well, we'll see. We'll keep going. I just checked these two little diodes that are there. They're a protection circuit for the input of that IC. They both check out okay, so they appear to have done their job and clamped and protected the IC. I'm hoping so anyway. They both measure fine, so they're both not blown, they work okay. So hopefully they've shunted the excess voltage from that to ground and protected the IC and only burnt that resistor. So fingers crossed that's what's wrong. I've also measured every capacitor on the board and they all check out okay. There's nothing looking bad anyway. Okay, so I've just removed the RF board, which is normally underneath the little shielded cover which sits there. There's the cover. Comes out quite easily, a few screws, little standoff here, it's got to come off. There's a little plug here, you've got to pull off the side. And the actual front panel can just go through this little plug. So you actually just slide the board backwards and it pops out. What I've found already, just from visual inspection, is this. That doesn't look very good. And as you see, it's on the input from the connector. There's a blown something and a burnt resistor. Again, I'm guessing this has been overloaded with something coming through the front end. So someone's been plugging things in the front of this which they shouldn't have been. I need to trace all this stuff and figure out where it's all going. But it looks like I might have actually discovered the issue. Those are grounds there. So it's got resistor to ground there. And there's a some part there, so it's probably a 50 ohm resistor which has been burnt out. And so there's another resistor to ground there. Yeah, I'm going to have to look at this really carefully. And even that's looking a little bit, might have got hot up there. So yeah, so at least I've actually found something wrong. You can see that's looking a bit dodgy, that solder joint. See that little crack in there? So that needs sorting too. So I'm hoping that hasn't gone too far. I'm guessing that's a resistor. So again, I have to go to my circuit diagrams and have a look and see what's there. But as you can see, the actual RF path is broken. There's a big crack in it. So that's stuffed. So right, next job. Okay, so those resistors, the left one there, well that pair actually, both 300 ohm resistors. That surface mount resistor there is supposed to be a 16 ohm. The circuit diagram and the manual is actually really hard to see. It looks, you can see it's a 1 and something, maybe a 0, maybe a 6, maybe an 8. Couldn't tell. So actually, because I had the second unit, I pulled that other unit apart and actually measured it, and I measured it at 16 ohms. So I'm guessing that's what it is. I just need to find a replacement now. Okay, I didn't have any 16 ohm surface mount resistors. I did have 33 ohms, however. So what I've done is I've stacked one on top of the other and replaced that resistor there, obviously, and given it a little bit of a clean up. We could probably use a bit more cleaning. The board seems otherwise okay. I did find that this tantalum capacitor here, the right hand one, is measuring a large ESR. It's about 10 times bigger than this one, but it's the same value. And I compared it with the other board and the other unit, and it's completely different. So that tantalum appears to be blown as well, so I'm going to replace that also. Right, so I've pulled the tantalum capacitor out. I've already replaced it. I'm just going to show you this on my little ESR meter here. That's what it's reading, 16 ohms, which is what I was getting in circuit as well, so it's no different. The other part, which is identical, is getting, if I can get the probes on there right, 5.2, yeah. The one I've just put in, 2.7. So even this one here might be slightly out. I mean, I might think that maybe I should replace that one too. I'm leaning towards doing it. The part actually doesn't have any markings on it. But a really close look, and I cannot see any numbers at all. I can't see any markings. not even a plus sign. So yeah, it's a 1UF 35 volt tant, according to the circuit diagram, which I can barely read. It looks like 1UF anyway. That's what I put in, so let's hope for the best. So I decided to replace that other tantalum cap because I just didn't trust the value. I didn't want it failing in a month's time, so that's that one done. Okay, so I've reinstalled the board, powered it up now, and it's now working. It's measuring okay. I've only got a 15 millivolt input, and that's fine. This threshold's supposed to be 10 millivolts, and that seemed to tie in with what I was doing just now. So it is receiving properly before. Now, whereas before I shone a volt into it, it wouldn't receive it. So that resistor repair and probably tantalum as well, or tantalum. I keep calling tantalums. Tantalum capacitor replacement as well probably helped. So I'm currently doing 25 kilohertz in FM deviation, and that's what we're getting. This does this over range thing, which is fine. So 25 kilohertz deviation, I've put up to 100 kilohertz deviation. There we go, 100 kilohertz, 101. So it's actually working just nicely. If I then do AM modulation, I've got it set to 99.5 right now, and that's what we're getting. If I go down to 50%, yeah, 51. So I do 10% mod. If I push the right button, it helps. There you go, 11%. So it looks like it's really close. Whether it's this which is out of calibration slightly, whether it's my Marconi, I don't know. I'm guessing this is probably slightly out because my Marconi actually matched quite well with that Marconi when I was doing testing before. So that is one unit fixed. So yay! Now I need to figure out what's wrong with the other one.